How are you, my lovely students? Welcome to our new science session. We are still in Unit 2, Forces. Today we will start with Lesson 2. What are some types of forces? All motion is caused by forces. Changes in motion are caused by forces too. Forces affect everything this skateboarder is doing. By the end of this lesson, you will be able to plan and conduct an investigation about balanced and unbalanced forces. Our objectives for today: to construct explanations about multiple forces acting on objects and explore balanced and unbalanced forces. To recognize that objects in contact exert forces on each other and that they usually have multiple forces acting on them. To explore the causes and effects of forces that are balanced, which result in zero net force and no motion change. A time to remember. What is a force? Very good. It is push or pull. Very good. When you pull something, you use force to move it toward you. When you push something, you use force to move it away from you. You might pull a closed door toward you to open it. Then you push the door away from you to close it again. Your arm provides the force that opens and closes the door. Now let me assess your prior knowledge about forces and motion and ask you some questions. Can pushes have different strength and directions? Of course, yes. Pushes have different strength and directions. Can pushes and pulls change the speed or direction of the motion and start and stop it? Of course, yes. What happens when objects touch or collide? Very good. They push on one another and can change motion. Please, my lovely students, open your books on page 90. Pushing back. If you push or pull an object by touching it, you apply a contact force to it. When you use a contact force to push an object, the object pushes back. If you pull on an object, the object pulls you. Look at the pictures. There are 4 pairs of contact forces. Label the forces by drawing arrows. I will give you time to draw the forces in your books. Are you ready? Let's start. What are the contact forces in this picture? Excellent. Parent pushing child on swing, child pulling wagon, child batting a thrown ball, parents pushing a stroller. Let's draw them together. Do you see the arrows? Please draw them in your books. Very good. We are still on page 90. My lovely students, try to solve number 3 by yourselves. You can pause the video, solve this question, then check your answers with me. Write the correct answers from the word bank to complete the sentences. Let's read the 4 choices together. Push, pull, toward, away from. When you push on an object, it moves farther away from you. When you pull on an object, it moves closer toward you. Good job. Carefully balanced. Pairs of forces are either balanced or unbalanced. What are balanced forces? Balanced forces are the same size and strength, but act in opposite directions, so there is no motion. When one force is stronger than the other and the forces act in different directions, they are unbalanced forces. Let's study the pictures and captions to discover more about forces. Look at this picture. The two dogs are evenly matched. They both pull with a force of 10. In this picture, the X marks the center of the rope at the start. The rope hasn't moved, even though both dogs are pulling. What is the cause of the center of the rope not moving in the picture with two dogs? Yes, each dog is pulling with the same force. What is the effect of two dogs pulling with the same force? Very good. The forces are balanced and the center of the rope doesn't move. Now, one dog is playing tug of war with a big horse. The horse is stronger and pulls with a force of 40. What do the numbers tell you? Yes, the numbers tell the strength of the forces. The dog will be pulled over the X in the direction of the horse. A much stronger elephant takes the place of the dog and pulls against the horse. The elephant is much larger and stronger than the horse. You can tell from the arrows that there is more force in the elephant's direction. You can add all the forces that push or pull on an object. This sum is called net force. If the animals pull with equal force, the forces are balanced. This is zero net force. The motion does not change. Now please open your books on page 91 and let's solve question 5 together. Predict who will win and whether the forces are balanced or unbalanced. Force A, big horse. Force B, big horse. Who will win? Of course, we will have a tie because the forces are balanced. Now, force A, big horse. Force B, adult elephant. Who will win? Of course, the adult elephant will win because we have, or the forces are unbalanced. Funny car forces. A powerful force from the engine pushes these race cars down the track. The cars move so fast that the brakes alone can't stop them. To stop the motion before the cars run off the end of the track, another force needs to act on the cars too. Forces acting on a car change from balanced to unbalanced when the car is speeding up, slowing down, or turning. When a car is motionless, forces are balanced. Use your understanding of the topic to complete the following statements. This car goes from not moving to moving very quickly. When the car is stopped, the forces are balanced. Very good. Pushing the gas makes them good job, unbalanced. When there is no motion, the forces are balanced. When the car begins to move due to pushing the gas pedal, the forces are unbalanced. My lovely students, you have done great job. Well done. It's time to say goodbye. See you soon.